my test this week, right?
Yeah.
Which means, what must be in the book? Right? Anyway, shall we do this again? So, we're doing blood today. Please match up your objectives with what you're studying, because I'm next to up for your test. Okay, the reason I'm showing this components of blood, which should be familiar to all of you already, is just to point out a few things. One, red blood cells can be normal red blood cell size and color when we're talking about anemias, or they can be large or they can be small. Okay? The reason is and let me draw this up there. You would have had some point in your life a chart that kind of went like this. If this was a blood stem cell, then that blood stem cell had the option to divide into any kind of blood product it wanted, right? So it would say it wanted to turn into a monocyte, right? So it would make like a monocyte. Kind of so, okay, fine. Or it could make like a lympho. Go down the lympho side and make like a lymphoblast cell, okay? Or it could go down the myeloblast side, okay, and make myeloblast. From that myeloblast side, it can divide into various things or turn into various things also. Like say it's going to turn into granulocytes, like your basophil, eosinophil, or neutrophils, okay? Remember this? Or it can turn into platelets, right? Little platelets right here, which are basically red blood cell fragments, more or less. Or it can turn into a red blood cell, okay? The reason I'm bringing that up is because, again, sometimes you will have an issue between the myeloblast state and the red blood cell, final mature red blood cell. And if you have an issue in there, then you can get stuck with a really large red blood cell. Okay? It's not a fully functioning red blood cell, but that's why, and it seems kind of odd, that you would have a immature red blood cell that's bigger than your normal red blood cell. Okay? So that can happen. So we'll talk about that when we talk about folate and B12 deficiency anemias. And also you can have really small pale red blood cells. That has to do mostly with iron and hemoglobin content. We'll talk about that too. Okay. Any questions on that? It's kind of a key point where it'll help you figure out what exactly is happening in anemias. Okay. At some point we will probably talk about polycythemia. Many sites, many red blood cells. You've probably heard about this before. It's kind of what the problem is when people blood dope. This is why they don't want you to do that, because there is a disease that does that, and that disease makes things really bad. You get lots and lots and lots of red blood cells, and your blood gets really thick and sludgy and can cause clots and aneurysms and all sorts of problems, high blood pressure, that sort of thing. Okay? And then, of course, we're going to talk mostly about anemia today. Questions on that? What is blood doping? That's when somebody will,
Lance Armstrong.
for example, maybe they will take their blood, like they're donating blood, take it out of their body, freeze it, cool it, whatever they need to do, until right before like an event where they need a lot of blood and oxygen, and then they like inject it back in themselves. Or you can do it like you can just take erythropoietin, which will make a lot more, which is how they mostly do it nowadays. And then that will make a lot more red blood cells, therefore you have more oxygen, so when you're doing the Tour de France, right, then you can kick butt because you got more energy than everybody else, right? So that sort of thing. That is not the same as what the world does, taking everybody up to Colorado to train so that they can make more red blood cells, so that they have more energy when they come back down and they can kick butt. That's slightly different, okay? The Colorado thing is legal, the other stuff not legal. None of them are polycythemia. But I guess you can do the Colorado version because that's unnatural and your body knows how to deal with that. It's not going to blow your vessels out or something because you have too much pressure. Okay? Otherwise, people in Colorado would have some issues. All right, quick review. If Edward Cullen was to suck out all your blood, how many 1 liter water bottles could he fill up? 1 liter, yes. I said 1 liter. How many 1 liter water bottles could he fill up?
Where's?
Fill up. What? Oh, you can't see because of the light? How's that? Better? All right. You haven't figured it out by now, you don't know. Moving on. What? All right, so I got 25, 1,000, no. Yeesh. 60, no. Okay, so anywhere 4 to 6 is fine. Okay, that was your quick review on that. Moving on. All right, so there's a definition of anemia. Read it yourself. I don't need to read it to you. Questions? Again, the main point of anemia, as far as clinically speaking, obviously there are more points, but the main point, you don't have enough red blood cells, therefore you don't have enough oxygen carrying capacity, therefore you run out of oxygen. Remember that mechanism. It's going to be the same for almost all of your clinical problems. Okay? And therefore you get very tired. It's a kitten. You're good. Okay. This is a key point. Okay? You need to know this. I put a key on there, a little key point, and now I'm going to draw it. We classify anemias by their size / volume because they do hold liquid. Okay? And by the red blood cell color, or amount of hemoglobin. Be careful about that one. Okay, so first, let's start out. You could have a red blood cell that is a normal size, normocytic. Yes?
Mm-hmm.
But you could still have anemia because you just don't have enough of it. Okay? You could have a anemia that has a microcytic, or small-sized red blood cell. Or you could have an anemia, like I was saying, that is macrocytic, or a very large-sized red blood cell. Okay? Actually, for illustrative purposes, I'm going to move that and make it bigger, like that. Okay? So when you're talking about the size, normal, micro, macrocytic. Okay, color is chromic. You can have a normal color. And let's say it looks like this as far as its normal color. Red, right? Same hemoglobin, because hemoglobin is what gives your red blood cells red color. Okay? Or you can have a hypochromic. Say that's like the density of your red blood cell. Okay? You see how that would be like less color? Okay, we're really talking about density here of hemoglobin that's packed in that red blood cell. Okay, and that's kind of where you can get a little messed up. Is what you do not see is you don't see a hyperchromic. Why? Because I like to think about it like this: hemoglobin needs iron. Okay, you got to have iron to make hemoglobin, right? Don't you? So if iron are my little beams, and again, I'm taking some liberties here. Don't tell the PhD physiologists on me. They will have a cow. But iron, you need iron to make hemoglobin. Okay? So if I picture iron as my little building blocks of hemoglobin, then I need these irons. Again, I'm definitely taking some liberties on how many irons I'm putting in here. But to illustrate the point, if I have my little irons, I am using those to build my hemoglobin, and my hemoglobin is my structure of my red blood cell, okay? So then I take my red blood cell, and that's what it's made up of. Still with me on that? Okay? Now, if I don't have enough iron, then I have less hemoglobin. Yes? If I have less hemoglobin, I have less structure. Therefore, my red blood cell will be smaller. And because it's smaller, because it doesn't have enough iron, which means it doesn't have enough hemoglobin, it's going to be more pale, because hemoglobin is what gives it the color. Okay? This makes sense. Okay. Again, I'm way, way oversimplifying this. Do not hold me to this if you decide to go on and become a hematologist. Okay? Because you're going to be like, oh my gosh, she totally messed that up. I got it. I know. But you know what? You'll remember this for what you need to know. Okay? Correct yourselves later as far as the detailed physiology goes. All right? So, you could have a hypochromic and microcytic cell. Because why? Yeah. And if you don't have enough iron, right? Decreased iron. When you guys think about anemia, typically that's what most people do think about is iron deficiency anemia. That's what we're talking about right here. You don't have enough iron, you have small, pale red blood cells. Okay? Now what if you happen to have a macrocytic anemia? You have that really big red blood cell, but you know what? I tried to draw it the same density as normal chromic. Okay? Notice that there's a lot more hemoglobin in that really large red blood cell. However, it's supposed to be the same density. Okay? I might have failed on that, but it's supposed to be the same density because it's the same color. Because why? If it's the structure that is filling up that red blood cell, you can have more structure. You just get bigger. So you can add more hemoglobin, but it's still the same density, therefore the same color as normal. Does that make sense? Or not? Because that's where people will get messed up. If they're going to get messed up, they're going to want to say you can have a hyperchromic cell because you have increased hemoglobin in the cell. It's not true. Okay? It just doesn't happen. As far as I know. Okay? Now, what you're going to see on a lab test are these. You're going to see things like MCV. That means mean cell volume, average cell volume. It's the same thing as saying average size, okay, of your red blood cell. So again, in that blood sample, what is the average size of red blood cells in the sample? Okay, that's the MCV. Right? Again, that's going to predict whether or not you have a small, normal, or large sized cell. Red blood cells. Okay? The other thing that we want to worry about is MCH. And yes, you have to know MCV and MCH. Mean cell hemoglobin, the average amount of hemoglobin in a cell. And again, be careful with that one because, yes, you can have more hemoglobin in the cell but still have the same color. But if you have less hemoglobin in the cell because you have a small cell, then it will be pale. Okay? Number 3, more or less, means the same thing as number 2, so I wouldn't stress too much about it, whether it's MCH or MCHC. It's the same thing, more or less. Okay? RDW, red cell distribution width. You will see this on a blood test. Honestly, I'm not sure the practical uses of it for you at this moment in your life. Just says, you know, this range of size of cells. Okay? So number 1, normal, micro, or macro is what you need to figure out based on the MCV being high, low, or normal. And number 2, determine whether it's normal, chromic, or hypochromic, depending on the MCH, whether that's high, low, or normal. Okay? Questions on that? Then moving on.